Good morning, guys. Today I'm going to talk to you guys about representing proportional relationships. Before we get started, there's a couple things that we have to make sure that we know or understand as we move into this lesson, some vocabulary. So we're going to start with proportional relationship and just kind of discuss what exactly is a proportional relationship. So as you can see here, a proportional relationship is a relationship between two quantities in which the ratio of one quantity to the other quantity is constant. So let's think or imagine that we have two items, two things, right? We have a monkey, we have monkeys, and bananas. And if we said one monkey can eat 3 bananas in an hour, right? One monkey, 3 bananas. Okay, well let's say we had 2 monkeys. If we have a constant rate of change, if the amount of monkeys goes up by 1, the amount of bananas needs to go up, has a constant change. So if one monkey can eat 3 bananas, that means 2 monkeys could eat how many bananas? Right, 6. Which means 3 monkeys, if we have a constant rate of change, could eat how many bananas? Very good, 9, right? So 3 monkeys would eat 9. So the rate of change is constant. Every time we add 1 monkey, we add 3 bananas. That's a proportion. We're showing a constant rate of change. Second thing we have to make sure we understand is what we call the constant of proportionality. The constant of proportionality, really simple, is the slope. So when we see our rate of change, the slope is what exactly is that rate of change. So in our last example, the monkeys and bananas, the rate of change was 3. Every time we added a monkey, we added 3 bananas. So the rate of change, 1 monkey, 3 bananas, that rate of change would have been 3. So we're looking at the slope is the rate of change. For this lesson, we're going to call the slope K. The state of Texas wants to call it K. So anytime you see me write the letter K, we're referring to the slope. Okay? Now in order to find that slope, we use an equation called y over x. So to find the slope, we need to know what a y is and we need to know what an x is. In our last examples, we talked about monkeys, bananas. So let's say that monkeys is our x and y is our bananas. So we would put y over x, 3 over 1 is 3. So in this proportion, our slope, like I said, is 3. K would be equal to 3. Right. There are 3 forms of proportions that we're going to look at. We're going to see some in tables. We'll see some graphs. And then equations. Our equations are always written in this form. Y equals kx. That's the way we'll always write our equations for the linear proportions. Now, we talked about this. We said the k is the slope. So in this example, what would the slope be in that example? Very good, 5, right? Y equals kx, 5x. So the slope for this example here would be k. All right. Now, in order for a proportional relationship, or in order for a relationship to be proportional, we must have 2 things. The first thing we must have is it goes through the origin. Those of you who are not sure what the origin is the coordinate plane, on the coordinate plane 0, 0, where x is 0 and y is 0. That is the origin. We're looking at a graph where x is 0 and y is 0, they'll go be right there. So in order for a relationship to be proportional, it must go through the origin. So if we had no monkeys, how many bananas did they eat? None. Right? So that would go through the origin. Right? No bananas, no monkeys. 1 monkey, 3 bananas. And later on in another lesson, we'll show how to plot that, but that's not for today. So it must go through the origin, and the second thing is it must have a constant rate of change, and we talked about what that looks like. That rate of change we refer to as the slope, or the K. Alright. 3 steps when working with linear proportions. First thing we're going to do is we're going to create a table. So we'll take our information, create a table from that, an X and a Y table, as I showed you earlier. Then we find the slope. We need to use K, find K. We're going to use the fraction Y over X in order to find K. And once we know K, then we can write an equation in the form Y equals KX. Alright, so let's practice. So we're going to take a look at, not this one, Y equals 4X. I want to build a table. I'm going to try 0, 1, 2, and 3. So what I'm going to do is I'm going to plug in 0, 1, 2, and 3 for X and determine what Y equals. That's a little bit of algebra. So 4, if I put in 0 for X, 4 times 0 is 0, so Y would equal to 0. That we call our what? Our origin. So does this relate, does this go through the origin? Yes. 1. So we would multiply 4 times 1. Y equals 4. All that. So we've determined that the rate of change here is 4. Every time X goes 1, Y goes 4. Let's see if that's constant, if that rate of change is consistent. It constantly changes by 4 no matter what we put in for X. Try 2. 4 times 2. 8. Y equals 8. Okay, 8 over 2 simplified is 4, so that rate of change is constant. We're seeing a constant rate of change. Let's try one more. We'll try 3. So when we put in 3 for X, we get 12 for Y. Again, 12 over 3 would be 4. Right? So our rate of change here is constant. It goes through the origin, it's constant, it is proportional. So our 3 steps: create a table. Second step was to find the slope, K. We said to find K, we create a proportion Y over X. I can choose any of these points to determine what Y over X is. We don't want to use this one though, okay? We don't want to use 0, 0. So let's use one of these 3. Y is 4, X is 1. So in this instance, our slope would be 4, right? K equals 4. So first step, plot the, create a table. Second step, find the slope. Third thing we had to do was write an equation. So our equation must be in the form of Y equals KX. We know what K is, right? 4, so Y equals 4X. And that would be our equation. Here you see Y equals 4X. Create a table, find K, and we have our equation. Y equals 4X. So let's take a look at this information. Right? We're going to just practice a couple. So it says length and width of various U.S. flags. First it's asking, is the relationship above proportional? Alright, I don't know. Let's find out. We have to figure out what is the rate of change. So we're going to go Y over X. Let's call length X, width Y. So if we're going to go Y over X, we have 1.5 over 3. We have 3 over 6. I'm sorry. Apologize. Let me do that over. We had 3 over 6. So we multiplied 3 times 2, right? Here, and we multiplied 3 times 2 here. So every time this one doubled, every time we added 3 here, sorry, as we're adding 3 to the length, we're adding 1.5 to the width. Alright, so every time we add 3, we're adding 1.5. Let's see if that's consistent. Plus 3 is 6, plus 3, plus 3, plus 3. We're adding 1.5, 1.5, 1.5, 1.5. So every time the length goes up 3, the width goes up 1.5. Okay, so is that proportional? Yes. If so, write the equation that describes the relationship. Let x represent length, y represent width. All right, so in order to write the equation, we have to find slope. So y over x equals k, correct? So in this situation, y, let's just pick 3. 3 over x, 6. K equals 3x, or we can simplify it 1/2. K equals 1/2. Right. So now we're going to write our equation. Y equals 1/2 x. Okay? So let's just see if that makes sense. X is 12. Is y 1/2 of that? 6? Absolutely. X is 9. Is y 1/2 of that? Absolutely. So is that logical? Does that make sense? Yes. Another flag in the same collection has a length of 21 feet. What would the width be? So now they're asking us to predict what the width would be if we know what the length is. So let's write our equation, y equals kx. And let's fill in what we know. We know the length is 21 feet. That is our x length. So y equals k times 21. We also know what our k is, correct? K is 1/2. So y equals 1/2 times 21. So what is 1/2 of 21? 10.5. Y equals 10.5. So if the length was 21, using the slope 1/2, we would have y equal 10.5. Huh? Again, they're giving us a table. We're asking, is it proportional? Write an equation, and then what if question. If x was this, what would y be? That's how you would determine that. All right, let's look at one more using a graph. All right, so our steps. First thing we need to do is create a table. X, y. This is my x-axis, right? So x is 1, y is 3. Here. When x is 2, y is 6. When x is 3, y is 9. When x is 4, y is 12. Okay, so step 1 was create my table. Step 2 was to find the slope. Slope equals y over x. Let's just pick any plot. 3/1, so y equals 3/1. Y equals 3. So now we know y. So plot take my plots, put them in a table. Find slope. Sorry, not y, that would be k equals 3, not y, I apologize for that, right? The slope is k equals 3. And once we find slope, now we can write an equation. Our equation must be in the form of y equals mx. So, I'm sorry, m, k. In Massachusetts, they called it m. Sorry about that. So y equals kx, so y equals 3x. So for this graph, our table would be y equals 3x. All right, if you have any questions, please feel free to contact me, email me at cgillpat@HoustonISD. That's 2 L's. Also, feel free to rewind anything that was confusing. Go back and rewind. Pause at any point, re-listen to it, and if I made any mistakes, I apologize. Good luck, guys. Hope you better understand proportions. Remember, it must go through the origin, and it must have a constant rate of change. All right.